Hi everyone, my name is Liggett. As Hannah said, I'm one of AEE's applications engineers, and today we're going to discuss rapid shutdown as it matters to you. Kind of a quick agenda. We're going to kind of discuss why rapid shutdown and what rapid shutdown is. We're going to go through a couple code variations to have some kind of description of each of them, from 2014 code to 2017 and 2017 post 2019. And we'll kind of get into that later on in the slide or into the presentation. So first off, let's get started. Why rapid shutdown? The primary objective of NEC 690.12 is to provide emergency response personnel with a comprehensive and effective means of controlling PV power circuits installed on or in a building in a manner that eliminates false sense of security associated with rooftop AC or DC disconnects. So whenever you're thinking about this, there's that false sense of security whenever you have DC disconnects on the roof. Whenever you think of throwing a disconnect, you think of disconnects and it's a safe, it then becomes safe. But with solar, anytime that there's sun or radiance, you have energy that's being produced and creates voltage, and it's definitely a hazard. So if you throw a DC disconnect on the roof, you still have potential from the inverter side and coming from the PV side. So rapid shutdown kind of addresses those issues and tries to make it safe for first responders showing up on site. And, when they throw a disconnect or initiate rapid shutdown, it essentially makes it safe for them to, begin addressing the situation on site. So next slide. What is rapid shutdown? So rapid shutdown is essentially a way to control the AC and DC circuits. For grid-tied PV systems, the primary objective is to control the DC circuits. On the AC side, grid-tied inverters comply with IEEE 1547 and are tested and listed to UL 1741. So during the loss of AC power from the grid, the conductors will actually shut down and are well within the time frame that the code requires. In standalone systems or interactive systems with battery backup, the rapid shutdown must also control any AC circuits that remain energized in the absence of utility power. So, that's the primary reason you have a battery backup system, is from loss of AC power. So you can continue to, have loads on your site that are remaining energized during a grid event or an outage. So, if the fire department comes to pull the meter socket to, or throw an AC disconnect or whatever to initiate rapid shutdown, essentially, that won't happen. So they have different provisions, and typically battery systems will have a button that initiates rapid shutdown to shut down the interior AC circuits as well. And we'll kind of get on that a little bit more later on in the slides as well. But the NEC requires conductors to be limited to 30 volts. And the reason why it's 30 volts is this is the safe or safer voltage for wet locations provided by the NFPA 70E standards and required. So this is under the 50 volt rating that hazard identification risk assessment procedure would not be required. If it's above 50 volts, then it limits troubleshooting to a qualified personnel. So this essentially makes it a lot safer in wet situations for fire department to be on site and to be working around these conductors. All right, next slide. Whoops. All right, so this is just a general map of the U.S. of NEC adoption by state. So, it's color-coded. Down at the bottom corner is the legend. So the grayish color is states that adopted the 2017 code currently, which is only Massachusetts. All the other red states are the ones that are currently on 2014. Blue states are 2011. Green is 2008. Down at the bottom here, I included a link. I'm not sure if this link will actually work. Depends on how the slides are sent to you guys. But feel free to email, and I can get this link out to you. Oh, yeah. Let's get to the next slide. Yeah. Okay, so this next one is essentially what NEC State is in progress of adoption and what code. So you can see all the ones that are in 2017 or that are under adoption of the 2017, the ones that are under adoption of the 2014. And there is also, that I didn't mention on the other slide, states that there is no statewide adoption of the NEC, which is the yellow states. These definitely recommend contacting your AHJ to find out what code they are working with, just to make sure that you're current and your systems are compliant. All right, so the next slide is the actual NEC 690.12 Rapid Shutdown requirement. So 690.12 Rapid Shutdown of a PV system on building. PV system circuits installed or in building shall include rapid shutdown function that controls specific conductors in accordance with 690.12 1 through 5. So I kind of labeled them out here. This is a pretty dry slide just because it's straight from the code book. I figured it would be good to kind of pinpoint each piece of it, and we can kind of talk about it. So requirement 1, requirements for controlled conductors shall apply to the PV system conductors more than 5 feet in length. And I underline that because we'll take a look at another slide and kind of discuss what that means. Inside the building or more than 10 feet from a PV array. Control conductors must be limited to no more than 30 volts or 240 volt amperes in 10 seconds. There was actually a TIA that was submitted for the 10-second time frame. A TIA stands for Tentative Intern Addendum. This was issued that relaxes the time frame from 10 seconds to 30 seconds and was effective the 24th of August, 2016. Line item 3. The voltage and power shall be measured between any two conductors, between any conductor and ground, sorry. So, be confident in this and aware, and be sure that, whenever you install this system with Rapid Shutdown, be sure to test and make sure that you test this and it's compliant and you are able to show the inspector that the system does comply and has reduced to 30 volts and the time frame allotted. The rapid shutdown initiation method shall be labeled in accordance with 690.56b, which I'll have a slide of that next. Equipment for that performs rapid shutdown shall be listed and identified. So this is the TIA that was submitted, relaxing the 10-second voltage limit to 30 seconds. And I actually have a link up here as well, so you can go directly to the site to reference this in case your HGA would like to see it. It's good to have on hand. All right, 2014 compliance. So this is just a general picture that shows the controlled conductor area. So, or I should say non-controlled conductor area. So we have an array on the roof and a 10-foot perimeter around the array and 5 foot into the building. So one thing I want to note is this is not a volume. So this doesn't say that you can run a conductor or run your PV source circuits into the structure and then route them pretty much in that 5 foot area underneath of the array. Does not allow the code. That's why I underlined in length in the first section of the 690.12, because conductors that are 5 foot in length inside the building are required to have rapid shutdown. So that's something something to keep in mind. On the outside, it does say 10 foot from the array, but there's really no reason for you to just route conduit around the array. You're going to want the straightest shot over the side to your inverters. But definitely something to keep in mind. All right, this is the signage required from 690.56. Facilities with rapid shutdown, building or structures with both utility service and PV systems comply with 690.12 to have permanent plaque or directory, including the following wording. Photovoltaic system equipped with rapid shutdown. So the NEC at 690.56 gives you a very detailed description of what the label is required to look like. Height requirements, lettering requirements, it's all detailed in there. You know, if you go through PV labels, they'll have the exact labels that you need to these requirements. So not too big of a hassle. All right, next is string inverter compliance. So this was kind of an interesting slide, and this is by no means all inclusive of every rapid shutdown situation. There's still, you know, tons of different variations, and I would actually confirm with your AHJ which ones of these are, you know, everyone has their different interpretations of the code, and they allow different aspects. So, for instance, if you look at number 3 here, where it's a 1-story ranch or bungalow, the inverter is actually mounted within 10 foot of the array. So technically rapid shutdown would not be required. But depends on how your AHJ would look at these. You know, you could get some kickback from them, and I don't know if it would be worth, you know, arguing with them over, you know, code articles, because typically they always win. But, you know, it's something to look into. It could save you some time and money during the installation. But let's take a look at number 1, 2-story home. So the array is on top of the building. The rapid shutdown box is up top within that 10-foot perimeter of the array. Conductors are coming off the right side of the building, which would be controlled down to the inverter because they exceed the 10-foot array perimeter. Number 2 is a 2-story home, but this time they put the inverter indoors underneath in the attic space, and the conductor length does not exceed 5 foot. In this situation, there was no attic cost, and rapid shutdown, it essentially complies with the rapid shutdown requirements of the NEC 2014. Down at the bottom, I have the link with this reference in case you guys wanted to read about this afterwards, you know, or have these as an example as well with the slides. All right. So I wanted to add a few different components. This is the Fronius Rapid Shutdown Box. I selected a few to kind of review, just you know, that are slightly different. Fronius Rapid Shutdown is initiated from loss of AC. It uses a 24-volt signal relay that's inside the Fronius inverter that connects to the Rapid Shutdown Box. This box will be mounted within 10 foot of the array perimeter to comply with 2014. And if you look to the left, this is a diagram of one of the larger Fronius Primo inverters. It shows multiple uses of the rapid shutdown box, and pretty much how complex some of these can get as well. You know, this has six different PV arrays to a single inverter. One thing that I would be aware of is some of these do have combining capabilities. Just be sure that, you know, you still are following the typical rules and, you know, not exceeding terminal ratings of the inverter if you're using one as a combiner. Just, you know, always read the data sheets, the installation manual, make sure you comply with all manufacturer specifications. The next one is a Jinlong. I chose this one. It's very similar to the, you know, Fronius Rapid Shutdown Box, but it uses a 240 volt AC signal wire. You know, one thing that would throw red flags for people is, you know, they expect it to run separate conduit for the signal wire to the control box, but technically you're allowed to run the AC signal wire inside the DC source circuit conduit, which, you know, helps save time. You just pull an extra run, as long as I'll have a slide coming up detailing the requirements for that as well. This one comes in just a 1x1 pass-through or a 2x2 pass-through. So I believe on this one, the second output you can actually combine a circuit on. So, just as I was saying before, be aware of that. Make sure that the inverter terminals can handle it, and you're not combining, various azimuths or pitched arrays on the same channel. AC control wires and DC conduit. The NEC will allow, under certain circumstances, AC and DC conductors to occupy the same conduit. Since the RFD AC control wire is a non-PV system or inverter output circuit, it can be ran in the same raceway as a PV source circuit as long as all the conductors have an insulation rating equal to at least the maximum circuit voltage applied to any conductor within the enclosure, cable, or raceway. So essentially that's saying that AC signal wire can run in the DC conduit as long as it's rated to a minimum of 600 volts, because that's what our conductors coming from the PV array would be rated for. All right, so now we're going to get into 2017. There were some slight changes in the 2017 where it, the code article actually was increased by about 130% from the 2014. They tightened up the outside array boundary and actually added a second part to B, which is B2, which is inside array boundary. This isn't going to be a requirement until January 1st, 2019, but this is where the interior array boundary is actually controlled wire as well that has to be reduced to 80 volts or less within 30 seconds. So the outside the array boundary in 2014, it was 10 foot with 5 foot into the building. In 2017, it's reduced to 1 foot perimeter and 3 foot from point of entry and limited to 30 volts in 30 seconds. In 2017, the initiation device, they actually gave provisions on sort of a location. In 2014, they didn't really have any of that information, and you could put initiation device inside, which wouldn't really make too much sense. But this is initiation device that shall be located and readily accessible outside the building, unless there was already something pre-planned by the fire department for an emergency situation that that would all have to be confirmed with your AHJ. And equipment shall be listed and labeled for providing rapid shutdown. So what this means is labeled changed from identified. So labeled means that it actually will be UL listed and tested for rapid shutdown. In 2014, technically you could take relays and circuit breakers and sort of create your own rapid shutdown if need be, as long as the equipment was well within the requirements of condition to use. But 2017, tightens that up and, gave manufacturers a little bit more time to create equipment that is compliant with 2017. So 2017, it has to be UL listed for rapid shutdown. On the right side, I have kind of a chart. So when 690.12b2 inside array boundaries comes into effect in 2019, this is essentially a list of how to comply with those. So first off, the PV array shall be listed and field labeled as rapid shutdown PV array. So listed by NRTL, Nationally Recognized Testing Laboratory. So essentially they'd come on site and list the whole array as being rapid shutdown compliant. Use module level power electronics, MLPEs, similar to SolarEdge, Tigo, Enphase, or BIPV products with no exposed conductive parts installed more than 8 feet from exposed ground conductive parts. So, essentially having a building integrated PV array with no grounded parts or exposed metal parts showing and fully integrated into the building. Next slide is pretty much a comparison between 2014 and NEC 2017. It shows the different limits and areas for controlled conductors. So this is actually the NEC 2019 version, or post-2019, where the interior array will be limited to 80 volts or less. So up till that point, we'll still be able to have that as an uncontrolled conductor, but we'll still have tightened parameters on the perimeter and the egress into the building. So you can see the 2014 10-foot perimeter, 5 foot inside the building, 600 volts. NEC 2017 post-2019 is 1 foot perimeter around the array, 3 foot interior, and limited to 80 volts. And all uncontrolled or all conductors outside of that array are 30 volts or less. Labeling for 2017 versus 2014. So 2017 added new signage to clarify multiple variations of rapid shutdown. So essentially, you really have 4 variations if you think about it. You have no rapid shutdown, NEC 2014, which is the 10-foot perimeter, uncontrolled conductors on the inside, and controlled conductors to 30 volts on the outside. NEC 2017, which is essentially the same, just a tighter perimeter, but then post-2019, which has the interior reduced shock hazard, essentially. So each one of these, the red label to the left, that would be for the pre-2017, or pre-2019, sorry, NEC 2017 code, and the NEC 2014 rapid shutdown code. The yellow would be for the shutdown with the reduced shock hazard in the array, so being reduced to 80 volts or less on the array interior. So this is, in hopes to provide safety response personnel with, a heads up essentially on what they're going to see on the site. So if they know if the interior of the array is, voltage limited with reduced shock hazard, or if it's still going to be 600 or in commercial 1,000 volts in that interior of the array, so they will know and have a good idea of what to expect on site. The buildings with more than one rapid shutdown. So this was implemented on the 2017 690.56C2, showing 2 different PV systems with a dotted line around the areas that remain energized after rapid shutdown switches operated. So this is essentially putting a placard up that would show the 2 various arrays. This one does a great job. Just has leaders coming from each array, and actually it's color-coded for what voltages are in the inside of the array during a rapid shutdown. So to the left, it's NEC 2014, which is above 80 volts. It will likely be 600 volts residential, 1,000 volts commercial. To the right, it's color-coded as kind of an orangish color, which is the 80 volts or less, which is the NEC 2017. So, this, again, will provide a detailed site plan for first responders, knowing that, the left portion of the array will be at a higher voltage. The left or the right portion of the array will be, reduced shock hazard. So in case they need to be in the inside of the array or around that area working, it'll be a safer environment. So this is just a quick chart of compliance per manufacturer. This is by no means an inclusive list or represent products that are coming out from manufacturers. It just kind of details, compliance between 2014, 2017, and 2017 with the interior array limitation. So, most of these Enphase, Magnum, GT500, and SolarEdge, the MLPEs, are compliant with all variations of code. Under certain circumstances, though, to keep in mind, SolarEdge commercial on the post-2019 that use the series optimizers, most of those series optimizers will exceed that 80-volt limitation. So Kind of curious to see what they're going to do to combat that in the future. The SMA, they're actually joined with Tygo for optimizer and shutdown solution as an MLP style. So they would be compliant using those with NEC 2017 post 2019. As of now, normal string inverters will not comply with the interior 80 volt limitation of the 2017 code. But I'm sure they'll be coming out with different products to comply with that shortly before 2019. All right, commercial rapid shutdown options. I just wanted to throw some slides in here briefly and some products. So the most common way to deal with commercial rapid shutdown is mount the inverter within the array boundary. So for 2014, you have a 10-foot array boundary that you're mount the equipment in, and you can have uncontrolled conductors in that area. The AC circuits off of it would be, lots of AC shut down. So it would comply with rapid shutdown. With 2017, you have a 1-foot perimeter, which would make it a little bit more challenging. It would almost have to be built in with the racking to be included in the array, but it still could be possible. The Pro Harvest I have on the right, this is kind of great for those two circumstances because this can be mounted underneath the modules. So you're definitely going to be within that 1-foot or 10-foot perimeter, depending on which code cycle. This only requires a 2-inch clearance on the top and the bottom. So you can really mount this thing anywhere as long as you have adequate clearance for cooling. You can mount it in any orientation as well, upside down, sideways. So, pre 2019, this is really a great solution if you have, limited space on the roof and you're concerned with shading with a normal skid mount inverter. Below, I have Innovative Solar 1000-volt combiner with rapid shutdown. So, this is the standard combiner box with rapid shutdown integrated. This has to be within that 10-foot or 1-foot perimeter. This will not comply, though, with the 2019 cycle of 2017 because the interior of the array would still remain 1000 volt. All right, module level power electronics. These are the easiest way with compliant if you have a technical array with a lot of jumps, a lot of distance in between it, and we'll kind of go over a layout where it exceeds that 10-foot or 1-foot perimeter. This could be the easiest solution. SMA paired with Tygo with their TS4 selective deployment MLPs. To be compliant with rapid shutdown, though, you do need the shutdown module on every PV panel. SolarEdge uses their DC to DC converters, which shuts down each module to a safe voltage range. Microinverters, they essentially eliminate DC wiring straight from the back of the module into the inverter, and the inverters mount it directly under the module. So it definitely keeps that limit, and it's a single module, so as long as the module's voltage doesn't exceed 80 volts, which it shouldn't, it's compliant with that 2017, both cycles, 2019 as well. So this is the 2017 RFD layout. This was from one of Bill Brooks' presentations, and it's kind of a good example because, typically, at least doing commercial, you don't run into the nice square blocky arrays too often. You have walkways you need to go through, and this details the section. So between, on the left side, the top and the bottom, you have a 48-foot, or 6-foot walkway between the arrays. So you essentially have 48 inches of conduit that's outside the uncontrolled boundary. So that means that cable has to be controlled to that 30 volts or less for this situation. And also shows going left to right as well. There's 24 inches of conduit outside the uncontrolled boundary. So everything inside depends on which, if it's post-2019 or pre-2019, the interior may not have to have a voltage restriction, but all the conduit leaving that is at a higher voltage than 30 volts needs to be controlled. So all of those conduits that are bridging from array to array must be controlled. You can get into some pretty complex layouts. In a situation like this, I would almost have to recommend an MLP or reduce the system or see, try to group everything together tighter if possible. But, you have to look at it on a case-by-case basis. All right, ground-mounted arrays. Ground-mount arrays may be subject to rapid shutdown when the PV circuits from the ground-mount array are physically attached or penetrate the building. 690.12 may be enforced. So you have to be careful with this, and I would definitely talk to the AHJ to confirm. We've ran into and heard of some situations where they mount the inverter on the side of the building, and just having the inverter mounted on the side, the AHJ required them to comply with rapid shutdown, even though, technically that might not be the case, and, but they have the final say in what they want, and, it makes it a tough situation to comply with if you already have everything installed. Buried conductors that come up into the building are allowed to run 5 feet before requiring a disconnect or rapid shutdown. So if it's buried and it's going underneath the building and doesn't touch the building, no way, then you don't have to worry about complying with rapid shutdown. But if they penetrate the building and run 5 feet, they are required to comply with rapid shutdown. 2017 has an exception. If the ground-mounted PV array circuits that enter the building and the building is the sole purpose to house the PV system equipment, then rapid shutdown or 690.12 does not have to be enforced. So if the sole purpose of that building is only to house inverters, switchgear, any other PV equipment, is not a dwelling whatsoever, then it does not have to comply with rapid shutdown. Battery-based systems, I'm going to just talk about this briefly. Battery-based systems require a separate initiator. Like I said before, if you pull the meter on a battery-based system, it's going to do what it's installed to do and just run in backup mode. So these usually require a separate initiator. So once the initiator is activated, it shuts down the PV circuits and the AC circuits of the interior of the building. Most rapid shutdown solutions are capable of connecting relay trip breakers that open control conductors at or near charge controllers in a rapid shutdown event. So if you have conductors that are 5 foot in length or longer inside the building, and the AHJ is requiring you to control those, these have the functionality to include a remote trip breaker. The array itself follows the same requirements as non-battery based systems, so it depends on which code cycle you're on. You'll have the 10-foot perimeter with 5-foot egress or ingress, or 1-foot perimeter with a 3-foot ingress. Things to remember: always confirm with the HJ your appropriate code cycle. Make sure you talk to them and everybody's under the same understanding, because they might tell you they're on 2014 code, but they have a different interpretation. You at least want to have very detailed notes, and at least, if they're trying to make you do something that you don't feel is right or not up to, the industry standard, have good articles to reference, reference the code, make sure you're familiar with it. Always remember to test the functionality prior to inspection. Be familiar with the terminology as well. So if you're, discussing the uncontrolled conductors, the controlled conductors, the array perimeter, make sure you know about labeling. and just, make sure you test it prior to the inspection. You don't want the inspector to show up and say, I want you to initiate rapid shutdown, and you just kind of look at it, blank-faced and say you don't know. Do your research, and, we're here to help you as well. But definitely make sure you know how to initiate rapid shutdown and how it functions. So resources, a lot of articles that I referenced. I tried to include the website that was referenced, and so you can have that information. Anytime you need to review, and feel free to contact AEE Solar as well, and we can send out some of this stuff. These are all links. Hopefully the links will come through on the slides once they're sent out to you guys. And always have the code book as well. Have the 2014, have the 2017. It's always a great reference. You can't, remember everything that's in the code. Talk to your local HJ and building departments. Lean on inverter manufacturers or the manufacturer of the rapid shutdown equipment. They're always great resources. They, nobody knows their equipment better, and there's always AEE Solar as well. All right, and that's all I have. Went through everything fairly quick, and I think that was pretty close to the 40 minutes.
All right, great. Thanks, Aaron. Great informative presentation. And we will start off our Q&A session. And while we wait for those questions to roll in, I'll just go over a couple things. Just a reminder that survey will pop up once you exit the webinar, so be sure to answer that. I'll be using the survey responses as a way to know who gets the NAPCEP continuing education credit. So be sure to complete that if you're looking for that certificate or a copy of the presentation. And also just one more thing, we will be putting this up on our YouTube channel. So if you missed any part of it or want to send it around to the rest of your team, it'll be up there by later today. So you can just search AEE Solar to find our channel, and you'll find this as the top video. All right, and let's just see what we have for questions. I know we had some about ground mounts, but we just covered that. So I think we're set unless anyone has any more questions. But the next one that we have is, are there any rapid shutdown options for off-grid that doesn't require an AC input?
That doesn't require an AC input? I'm not sure what they mean by that question. Maybe if you email me directly with your question and details, I can respond to that one separately.
Okay. Great. So if anyone has any other questions, feel free to send those in, and we'll answer those. Okay. Let's see. We have another question about ground mount systems. If a system has a charge controller in the building less than 5 feet away from entry and the inverter doesn't or requires disconnection, do you have any input on that?
Can you read that again? Sorry, I was putting the phone on speaker.
Oh yeah. So someone has a question if rapid shutdown is required for ground-mounted systems, and if they have a charge controller less than 5 feet away from the entry, does the inverter require disconnection?
Less than 5 foot away from the entry of the building? Well, if the DC conductors are over 30 volts and they're in the building and they're more than 5 feet in length, then it would require disconnecting. But the AC would have to be disconnected as well during a rapid shutdown event, no matter what. You wouldn't want it in backup mode because that would be a false sense of security. The fire department would essentially pull the meter and expect that nothing be live in the house, but then circuits are still live. So the AC would need to be disconnected, and the charge controller output circuits, if they exceed 5 foot in length, would need to be or comply with rapid shutdown as well.
Okay, great, thank you. All right, if anyone else has any questions, feel free to shoot them over. Otherwise, I think we've answered all the ones that we've received. All right, well, sounds good. If anyone does have any questions, feel free to email Aaron directly, or to shoot an email to myself, and I can forward it and route it over to the right person. And also, if you have any other questions on Rapid Shutdown products, you can reach out to your AEE sales rep. If you're not sure who that is, feel free to contact me, and I can forward you to the right person. And also be sure to check out our website for all of our training opportunities. You can find it just on our website, AEE Solar. Under trainings and events, we have some workshops coming up and a lot of webinars. So go on there and register for all of the ones that seem interesting to you. And if you missed any that you wish you could have listened to, you can find them all on our YouTube channel, AEE Solar. So go ahead and review some there. Our next webinar is June 23rd, and it'll be a new product showcase. So really interesting. We'll go over some new products we're bringing on board and what's coming up. So you don't want to miss it. All right. Well, thank you again, Aaron, for your presentation.
Yeah, no problem. Thank you.
Have a good weekend, everyone.
Bye. Thanks. Bye.